We live in a world which is exceedingly complex. We as humans are always trying to learn new knowledge. And so a scientist fundamentally takes what is unknown and brings it into the human consciousness. So in some sense, simply bringing it into the brain, studying our world and our universe and bringing it here. An engineer is often charged with designing a device, a system, or a process, and usually it's an immediate need. And so what an engineer does is take what is known to the human consciousness and goes out and solves immediate problems. Over time, over a period of decade, an engineer might be asked to do a very similar problem. But what has happened is the scientists have now learned more. So in some sense, engineers are using what is known today in the human brain and the human knowing to solve problems. And scientists are always restocking the shelves of knowledge. So one is scientists are bringing it into the brain, and engineers are sort of using it to solve problems.
Scientists and mathematicians in some ways are discovering for the sake of discovery. So a scientist, like a physicist, might try and understand how the universe was created, or what are things made of down to the smallest particle or component. An engineer uses those principles to solve a problem or to create something that might have a purpose that can be used. So for example, you might use the chemical principles as a chemical engineer to develop packaging so that a product like cereal will stay dry and moist in a box. As a structural engineer, you might use physics to design a structure that meets architect's vision, that stands up, that is durable, that you're using Earth's resources in a sustainable way.
So science is often thought of as the pursuit of the basic knowledge that describes the natural world. So coming up with theories that allow us to understand how the natural world works. And then engineering is often put at the other end, which is applying those theories to real-world important problems. So those are sort of the two ends of the spectrum, but often they get blurred together because engineers are often developing new knowledge and new theories as they're trying to pursue these important problems. And scientists often find that they're solving big problems while they're pursuing new knowledge. And so they really work together extremely well.
It really is, I guess, critical today that young people understand that whether they're a scientist or engineer, they're going to work in teams and they're going to solve problems. And they need to, first of all, be well-grounded in mathematics because modeling is critical. Computer science allows us to solve mathematical models that are not tractable otherwise. And the physical sciences give us the actual underpinning that brings it all together.
I would tell a student to invest the time to look into the different possibilities at the end of this tunnel. That means go talk to faculty, go talk to students who are juniors and seniors, go talk to people that really have these jobs and ask them, what do you do all day? And find out if that's what you want to do all day. So you need to reach out and start to talk to people and find out, what does it mean to be an engineer? What does it mean to be a scientist? What do those jobs entail when you get there? And that means investing the time to talk to people that have those jobs. So I'd say reach out to the faculty, reach out to the students, start that process, take the time to talk to people.
I think it's really important to get involved, that there are a lot of resources here on campus. Sometimes, because students enroll in the College of Science and Engineering, they don't realize that they can get involved with departments at an early stage. So one thing I would say is get involved with student groups. There are things like Solar Car, the Concrete Canoe or Steel Bridge Team, all different things, Tesla Works, where students that get involved at that early stage are then working with students in the program, and they can find out, can I see myself here in the future, and also helps them create leaders.
Ask questions. Talk to your faculty. I think every faculty member here, regardless of department they are in, has had experience both from the perspective of an engineer and a scientist. Talk to companies, talk to young people at companies and find out what those companies do. We often have false impressions of what a company X might do or might not do. Certainly we have great resources in our Career Center. The Career Center will also direct you to faculty for sure and companies, and there's also mentor opportunities, either to mentor with upper division students or mentor with young people from industry and get their perspective. But ask questions, be curious, and I think every undergraduate should try research because research is where those two come together. That's where you start to understand, like, why am I doing this? And yet I don't know what I need to know to do it right.